Okay, do we have a handshake dollar or $2 bill today? Yes.
I got it, and I decided to pick the second person that shook my hand after I sat down. The first one was Lynn, the second one was Steve Maier.
Getting paid for the program today. Huh? Anybody have any other announcements? Richard, did you have any people volunteer to help you on the...
I've got a helper for this Saturday. We're having a class reunion down here at the Moose Lodge. And Larry's going to be down there helping me pedal a few Afghans there. Sold 2 this week. I need some people to be with the Nescatunga Fair on the Square a week from this time. We're going to set up a deal down there. I think we can sell what we have left at that occasion. But we'll need people to man that booth, probably a couple of people from 8 o'clock till 2 o'clock and 3 o'clock in the afternoon.
Yeah.
So, if you have any interest, we're going to need some help. Raise your hand or get in touch with me.
Okay, Arden was not going to make it, but then he did show up. So do you want to come introduce our program?
I'd love to. I see that Alan Wilson has a guest too. Alan, would you like to introduce?
Yes. My brother-in-law, Colorado Springs, Bill Hornboss.
And Alan, I understand you can spell Hornbossel, is that correct?
It took me a year to figure it out, but there's some stuff in there that shouldn't be. He's not talking about me personally.
And Steve can certainly use that $2 because he has 3 daughters, the oldest of which will get her driving permit this summer. Steve and his wife, Amber, have lived in Alva since 1998. She works for Northwest Family Services. He works for the science department at Northwestern. And I'm glad to welcome him today. And he's going to tell us about the Seismograph, which is located at the College Farm south of Alva. Steve Maier.
Well, thanks, Arden. Thanks for letting me talk about this little project. I think it's kind of a neat little partnership, something that we were contacted by. So we were actually sought out by the Geologic Survey, and they were curious if we were interested in setting up a station. And I didn't know exactly how we wanted to do this. I don't have a PowerPoint with pictures. Really, the most exciting thing was me digging a hole in the ground, because that's all these things are. They're really not very exciting to look at. In fact, when he first contacted me to have it installed, he said, well, there are 3 options. We can install it outside, we can install it outside but plugged in, or we can install it inside. And at first I was pretty excited. Well, let's install it inside. We just need a concrete floor, and that way my students can go and we can look at it and take just for the experience of looking at a seismometer. And then he sent me pictures of what it would look like, and they're basically cases, orange cases. Everything is pretty tightly packaged. And so I said, well, you know what, it's not much to look at, so we'll just put it outside. We'll find some place for it. So the good news is it is completely outside, out at the farm. It's out by the Mesonet station. We don't really advertise a whole lot where it's at because we want to keep the traffic down, but and that's kind of how they prefer it. They like these seismometers installed on locations that are privately owned, or locations where there won't be too much traffic, because somebody just walking by these seismometers will pick that information up. So that's where it's at. It's out at the farm. They contacted us probably in September 2015, and we were installing it in December. I think it was the one time where we actually had snow on the ground is when they chose to arrive, and we were digging. It's probably one of the coldest mornings. So we dug 2 holes. There were actually 2 different units. The holes were probably just about, I don't know, 1.5 feet, 2 feet in diameter, and then we dig them down about 36 inches. And they put in some base sand, and it was kind of interesting because there were these 2 pieces of equipment which are tens of thousands of dollars a piece. They're pretty expensive, but they don't look it, because in his office, what he did was he used some PVC to completely encase this. So it's the piece of equipment is actually quite small, but it's inside a 4-inch PVC, Schedule 40, bolted, sealed with gaskets, and all sorts of silicone, so that prevents the moisture from getting in. So they just look like these pieces of pipe that we put in there. But put that base coat in, he put that sensor down, and then he had this other piece of equipment which just looked like a toolbox. But he said, well, this piece of equipment is actually about $80,000. And it was just, had no buttons, had no switches. It just had these like 3 or 4 different plugs. And he connected it to his computer. And I mean, it was literally like a toolbox. And he put it on top of the sensor inside the hole. And it basically aligned it. So it was essentially a gyroscope, a 3-dimensional gyroscope, but it was electrically driven by the computer. He said, no, this goes with me. This doesn't stay here. So it's pretty impressive. He just came out, and one day we dug the holes, put him in, and then he was on his way. You have some seismographs, and those seismographs are fairly recent tremors. The font's pretty small, apologize for that, but the top one is the 5.1 magnitude. That was in Fairview, and then the one at the bottom was an earthquake, or tremor that was experienced, we felt it here in Alva, on January 7th. I remember that one specifically, and the reason why I looked it up was because my wife and I were on our way home, and we were on Route 11, and Leah was home alone waiting for us to get there, and it was kind of late. And she calls us. Of course, we're driving, so we're not going to be able to feel anything. But she calls us, and she says, why is the bed shaking? So I don't know. Why is the bed shaking? Well, it's been shaking for about 20 seconds, 30 seconds now. And, I guess, it was really moving. So that was actually 2 separate tremors. And you can see the 2 different peaks on that. But these are actual data sets that were collected from our sensors. And we actually have 2 sensors in the ground. One sensor is a broadband sensor, and it's a sensor that's very sensitive to high frequency motions. So this is the one that basically if the wind is blowing, we've got the mesonet tower that's about 15 feet away from the seismometer. When the wind blows and it pushes that antenna back and forth, the seismometer picks that up. It picks up the frequency of that tower going back and forth. It actually picks up changes in the position based on daily warming and daily cooling. So they can tell by looking at the data, if they set the right filters, they can tell when sunset was and when sunrise was because the temperature of the ground changes. So it's a really sensitive piece of equipment. It's broadband. It's very good at registering low frequency and also very good at registering high frequency. That's why it's called a broadband sensor. The other unit, which is right next to it, probably just 2.5 feet away, is referred to as a strong motion sensor. And it doesn't start recording until it's triggered. And it's only triggered at a certain magnitude earthquake. You really have to jostle it before it starts to record the data. So both of those sensors have, they measure motion in north-south, and they measure east-west, and they measure up-down motion. So when you are queuing in the sensors, what kind of data you want, you have to specify which axis of rotation or axis of motion that you want. Any question?
I was just curious, you said it was censored by pretty significant jarring or activity. So you have to put these where there are cattle?
There are cattle out there. And so
somebody run the tractor over the top of it or something like that? Or?
Yeah, we made sure we fenced it in. So it's right off the mesonet. So the cattle can get near it, and he wanted to make sure when he was there installing it that it'd be protected from the cattle because they get wrapped up in the cable and do some damage. But it's fenced off, so the cattle can't get right on top of it. But as the cattle walk by, they'll be able to see the footfalls of the cattle, or the hoof falls.
Did you have to power it? I mean, like lay a power line to it?
No, it's completely solar powered. So he's got 2 solar panels, and it powers the seismometers, it powers the digitizer, it powers the router, and the cellular device that transmits the information. So it's not run on any city utilities at all. It's a pretty neat little piece of equipment.
to get these graphs, you had to put in some requests for data, you said for the axis.
We do.
How do you tell what that is? Can it say on there?
Yeah, so there's a story here. I was so excited about the seismometer. I said, yeah, this is something our students could get into, and we'll be able to look at the data. You know, if we hear about a tremor, earthquake, even if it's not in Oklahoma, this will be able to register events in California because earthquake data, it travels. And we'd be able to see those data if we applied the right filters. It turns out it's pretty technical if you want to get the data. So just for starters, there's a web page you can go to. You've got to select the sensor, which isn't too bad. You've got to enter in some fields. But then you've got to enter in the date and the time, which you wouldn't think is too difficult, but it's actually it's not Central Standard Time. So if there's an earthquake that's at 10:30 p.m., what you have to do is you have to actually add 6 hours, convert it, so it's in Zulu. So you have to do a time conversion to make sure, because it's a globally operated system, and it's in kind of a global standard. So I have, if you're interested, this is, on one side it is my own little cheat sheet as to how to access the information, and then on the other side is a snapshot of the web page that you would see and where you would actually enter that information. We've tried to be transparent about this because we think it's kind of neat, and really there are hundreds of these seismometers that you can access. They're open to the public. The trick is knowing what the site is and knowing how to get to it and knowing what the codes are. So this will give you all the information to access our seismometers data. And some people from the community have replied, and I've sent them documents, and so they're looking that stuff up. So I'll pass these out too. No, so it's not like a real-time applet where you go to a web page and you can just look at it real time. It doesn't function like that. You've got to set in a time range. Now, as it turns out, to get these, I put in a time range that was just on the order of a few minutes to get the very beginning and the end of the activity. But you can put in a time range of months. And if you put in a time, you get a pretty big spread that way. I'd probably recommend going, like, if you hear of a seismic event on a certain day, I'd put in the entire day, and you'll see little blips. And based on what you see on the horizontal axis, then you can narrow your search a little bit and hone in on a specific event. But you can generate longer data sets. These are just a few minutes long.
The blip would be probably very small on a long-term.
Right. Yeah.
But you can see where it's at and hone in on that.
Right. Yeah, once you know how to use it, of course, this is true of anything, right? Once you know how to do it, it's not that bad. But I tell you, it took me some time to figure it out. It's very sensitive to syntax, and it's not friendly if you get it wrong. If you get it wrong, it just says, nope, error, won't work. No suggestions as to what was wrong. You just have to go out and go back and figure it out. So the story is, I was wanting to do this for my general education students, Earth and Space Science, and I tried it, and it failed miserably because there's just a lot more guidance that's needed. The output here also, if you look at the graph, it has time is on the bottom on the horizontal axis, which is easy enough to understand. But then there's a count, and it just says count times 10 to the 6th. I'm like, what does that mean? I didn't even know. So I emailed the guy and said, what's going on here? And he said, oh, well, that's in order to get that to something meaningful, you have to multiply those values by this scaling factor, which has a ridiculous amount of significant figures. And I'm like, okay, so what do you do? What does that give you? He says, oh, well, then it gives you a rate. So this count is actually a rate of motion. It's not how much it's moved. It's how fast it's moved. I said, okay, so then if I want to figure out where an earthquake was, you have to know how far something was displaced in order to figure that out. This gives you how fast it was displaced. They say, oh, well, then you need to integrate it. So my students, if they're going to do this, they've got to multiply by scaling factor, and then they've got to integrate the function. And then once they get the function integrated, then they have to use this other algorithm. And I said, oh. So I do show the information, and I do offer it up as an additional project for them. I think that the better benefit of this is just a partnership between Northwestern and the USGS. Something that we both can kind of latch onto and say that we're working together on something.
Steve, what's the
primary distance right now that you're monitoring for span? Is it 50 mile or 20 or?
Probably yes. I mean, this is sensitive that it can measure. You know, it would have registered the earthquake activity in Prague, so it has pretty high sensitivity. And again, it would pick up on earthquakes if they're significant enough from California. We'd be able to see data from
But you don't
events that
have
far
a
away.
machine set for that far distance, do you?
Well, it receives everything, and then what we do is we have to apply the when we get the data. Right, there aren't actually any filters on this. We could actually run some filters, and we could like subtract off the AVAR train noise. We could subtract off things like the mesonet frequency of going back and forth. These are all things that can be subtracted from these to get those specific events, or to get rid of those so we can isolate a single event. But the reason why it was installed where it was because we noticed, or USGS, noticed a spike in seismic activity, and they wanted to record information on aftershock tremors. So I'm trying to be careful in using the word tremors rather than earthquakes, because these devices are really intended to measure very high frequency oscillations due to aftershocks related to the earthquake activity that's in north central Oklahoma. So that's why they selected our site. They saw, well, we need something in the northwest corner of Oklahoma, and Northwest University was right here, and they like partnerships with the universities because we tend to take care of things a little bit better. Yeah.
Why is the information on the aftershock so important to them?
Because well, I mean, it's just an active area of research. You can tell things about the nature of earthquake activities. I mean, these seismometers are right at the surface, and so they're getting information about what's happening, like right at the surface, the waves that are traveling. For different earthquakes at different depths, aftershock information is more accessible. Our earthquakes are fairly shallow. I mean, we're not having tectonic earthquake activity. So our earthquakes are a lot more shallow. And so as a result, it's kind of an opportunistic time or place to get that aftershock information, because it's, the seismometer can be really close depth-wise to where the earthquake was. For tectonic activity, that's generally a lot deeper, and so your sensors aren't nearly as close to where the activity is. So it's just an area of research. I don't know what more to say beyond that, other than you've got all sorts of different waves. You've got P waves and S waves, you've got surface waves, and then you have the aftershock, which can tell you something about the immediate geology with how these waves are kind of reflecting off of rock material.
This little graph here, for instance, all those lines, each little line represents something. How do they sort out? You said they could eliminate or discard some of the lines that were normal.
Mm-hmm.
So if they looked at this, they can't do anything like that from this. What does this tell them? That picture right there.
Well, this picture right here, these are significant enough that if we were to subtract off all those other things, they would essentially look the same. Now, if we were to take earthquake, like right now, let's say there's not anything happening right now, we would just see a lot of noise, and it would be very similar to just like these little tiny peaks. So if we were to subtract those off of this whole thing, we'd essentially see kind of the same thing. So these spikes right here are basically a measure of how quickly the shifts have taken place. So the higher it is, the more rapid the motion was in that particular axis. So for this top graph, what really I should have done was I should have printed off 6 graphs, because this is only giving us, this says it is HH1, which means I think that's north-south motion. So this is only giving us north-south motion, right? I should print off 6 so that I get this, and then I get this, and I get this, and then you can kind of layer those pieces of information. You can actually kind of see whether the wave was going like this in one direction or going like this in one direction, or whether the wave was going like this. So to answer your question, this single graph won't give them a whole lot of information.
Well, this isn't telling us anything about what direction from your sensor that this took place.
No. No.
That, you have to get all the information from all the sensors around and then extrapolate
Yes.
to find the epicenter.
So
Basically, they're extrapolating by the waves, aren't they, what type of geology is under the ground?
Mhm.
What
Yeah.
formations are under the ground that are causing those waves to bounce different ways or react?
So in part, yes, they can use this to help determine the geology of the local area. They can also use this to determine the nature of the tremor itself.
I mean, like where it originated from, or
The energy
how it
level.
traveled?
Yeah, the energy level. Obviously duration, but and I'm.
Can they get depth?
So the answer is kind of yes to all of those, and you're right in that they have to extrapolate. So there's a lot hidden in here, and you're not going to be able to get it all out until you make comparisons between our station and at least 2 other stations. And once you get those 3 minimum stations, then you can start to tease out and say, okay, well, we've got up-down motion here, but we've got north-south motion over here. So how is this wave propagating? And why would it be propagating that way? Is there something in the geology that's causing reflection, kind of diverting it? Because waves get diverted. It's just like light passing through a glass of iced tea, and you're looking at a silverware, and the silverware looks bent. It's because the light wave gets refracted, and seismic waves also bend, and they get refracted based on the material they're traveling through. Question?
Those waves follow the shortest time path. So based on the rock density, they may have gone roundabout to get here. Is that correct?
Say that again?
Earthquake waves follow the shortest time path.
Oh, okay, yeah. So they don't necessarily travel in a straight line, right? So it's minimizing the time of travel rather than distance. Yeah.
If Alan falls out of bed in the middle of the night, will it show up?
It may. Yeah.
Depends on how many times he bounces.
This won't be the only sensor that shows up on these.
I
Stations
think this
besides
subject
us,
should go on.
where our next closest station.
I don't know for sure where the most immediate stations are. I know that our stations are a little bit different in that they're technically a temporary station. So they put them in the ground, and they said, okay, well here they are, and they're made to be mobile. And he said these will be here in Alva for maybe 3 months, maybe 3 years. He said he's buried some of these in the mountains of Colorado, and that was 8 years ago, and they're still there, and they're still sending data. I don't know where the closest ones
There used
are.
to be one in Alva.
How can you tell
Yeah.
the difference between a tremor and an aftershock?
That's a question I can't answer. I think tremor is more all-encompassing, right? So you've got tremor is just, if there's motion, it's seismic activity in general. Then you've got, an aftershock, which is secondary to an earthquake due to like tectonic motion or a fault, movement along a fault. So that's the best I can do. It's the best I can do.
Do you know what faults that are near in this country?
Madrid, one
Yeah,
in Missouri.
Yeah, in Missouri. We also have fault lines in Oklahoma that kind of runs north-south along I-35.
My
Yeah.
wife is always my fault.
Of course it's your fault, Bob.
Yeah.
Steve, is this tremor scale showing the dates at the bottom? I mean, it appears that they've gone down significantly. Is that, fracking reduction and water injection reduction? Is it the explanation somewhat, or?
Yeah, those are the explanations being offered by like the OCC.
It's pretty
and-
significant
yeah.
reduction.
Yeah, there's and if you, the dates are there, so you can kind of put a timeline to the policies that have been put in place, and you can kind of see how they've impacted. The thing about seismic activity is that when something takes place, it might not be immediate that seismic activity results. When rocks are placed under stress, it may be time before they fatigue and actually there ends up being seismic seismic activity. And by the same motion, if you have additional stress at one location, like right here, it's not necessarily right here that has the most significant seismic activity. I mean, if this is a layer of rock and I push the table, right, the whole thing moves. And there may be some areas that actually have increased seismic activity than rather right at the source. So, you know, people have been very careful about talking about cause and effect and pointing fingers. And part of the reason for that, even the scientists themselves, is because it's very difficult to say, well, you know, this specific well, this specific activity caused this specific earthquake or tremor or whatever you want to call it. But it's very difficult to do because we're not talking about just a simple table in a completely rigid layer of rock. But yeah, the decline is noticeable. And just to put this in perspective, if you look at the vertical axis there, I mean, those are in the hundreds. So, you know, we're on the order of hundreds of earthquakes or tremors per month. Then I went back to 1990. This data, by the way, I just got this off of Oklahoma Geologic Survey website, and they've got a spreadsheet. You can just download it, and then you can look at the data. And what I did was I sorted it, and then I deleted all the activity that was less than 1.0, and then I just, you know, ordered it again. Going back to 1990, in all of 1990 in Oklahoma, there were 36 tremors for all 12 months at 1.0 or greater. So we go from 36 to the current rate. Even where we are now, we're still averaging 5 earthquakes a day, 5 tremors a day. A day. Yeah.
So we're still running 150 plus a month.
Yeah.
In Oklahoma.
Yeah. Yeah, we're still in Oklahoma, the whole state. We're still above 150 a month. Yeah.
Consider, no, in May of a year ago, 800.
Yeah. Yeah.
Steve, you were talking about the sensitivity of the equipment, and there's several rail trains and all that kind of stuff, and you're talking about being able to, how does it sense through an earthquake in California with all the ground clutter between here and there? How does that work?
What they do is the best I can tell, and I don't work at their office, but the best I can tell what they do is knowing that Avar train station is so far away, and they get some baseline data. So when there's no activity, they look at the seismic activity that's generated from that event, and then they use that as a baseline, so that anything else that's going on, they can then subtract that baseline data off of the noise that you would get from a different seismic event. Does that make sense?
Okay.
So
isn't that equipment's not going to pick up a train in Arizona?
No.
Oh, okay.
No.
Just stuff that's going to be felt here.
Yeah.
And you pull out the stuff that crosses that between here and California.
Yeah, it's a little strange when you think about it. You know, what's the range of these sorts of things? But surface events, it's only going to be able to measure things very locally, right? The trains are at the surface, but they're fairly significant, and they kind of create this rumble, constant noise. So locally, stuff at the surface, it'll pick up. But if you get beyond, you know, a 10-mile radius, it's not going to pick up anything at the surface that's regular traffic or regular noise.
Okay.
Yeah.
Are you able to set these instruments where they register things? Do they concentrate on different depths? Or just,
These specific pieces of equipment are temporary, and they're designed to be just a couple feet below the surface. So they, I mean, I suppose you could, but they've got kind of a standard. Like, I mean, he was measuring the depth and making sure that he got the depth so that it was consistent with the other surface instruments they've got nationwide. So I suppose it could be, but again, in order to get depth information, you need to have 3 different seismic stations giving you data, and then you can kind of filter through that.
Is the information that thing does, is it transmitted somewhere, or do you guys do that?
It is all maintained by the USGS. So there's the people who came out. So it was kind of interesting. So Steve Plotz was working with me, and then Steve Roberts came out to help me install. Steve Thompson was there. We were with Steve Sneary, and then I was putting a shovel in the ground. But he set it up, and he said that he's out of Albuquerque, New Mexico, and he said his office, their primary role is to make sure that the data are coming from that seismograph station to his office, and then they package it in a nice, neat form, and then they send it off. They send it off to the USGS. So we don't really have our hands in it at all, other than it's on our property and we have access to the data that it generates. So yeah, it's directly from a modem and a cell tower that's right there at the solar panel. It's beamed directly to Albuquerque, and then they ship it off from there. Yeah.
Was there anyone on site that day whose given name wasn't Steve?
There was a student, and I forget his name. If it's not simple, I forget it. So,
Is the earthquake we had a month or so ago, was that the largest one been recorded in a while in Oklahoma?
Remind me, what
Oh, it was like a 5.1
was that?
or
The one in
something?
Fairview? Is that the one that we're? Yeah. That's the most significant one, and in fact, that I think is on this right here. I wasn't sure if there was one that I'd missed, but yeah, I don't think there's been one that significant in this area.
Come the summer growing season, is there anything special that you have to do with regard to like keeping the weeds down and that kind of stuff?
It's Steve Sneary manages that land, and I've been out there because I had to replace a modem. The unit went down, and he shipped me a new modem, and I went out with my khakis and my button-down shirt, and I'm there with the cattle installing this modem. But there's not really a whole lot of overgrowth there, so I don't think there's a whole lot that we have to worry about. And I don't think that there's a whole lot of there's not a lot of heavy equipment immediately nearby. So. One of the things I was worried about was vandalism. The last story, and then I don't know what time it is. Are we done? Yeah. So I asked him about vandalism and if he's ever had to worry about that, and he said, well, not really. People are generally pretty good. Although in Idaho, he had some on public land, and it kept getting shot at because they had a U.S. property of U.S. government. So once we took that sign down, it's been working.